out on vacation right now with his family. Thankfully, well needed. I just got back from a vacation yesterday, so I'm really happy to be back and giving you this update today. Today, we've got a lot to cover. We've had a big vLLM release, and we thankfully have a great deep dive into the tool calling support and infrastructure built in vLLM over the past several years and months from Rob and Ben from Red Hat AI as well. Yeah, make sure I do an introduction myself. I'm Michael Goin. I'm a core maintainer on the vLLM project, working on it for almost 2.5 years now, and I'm a senior principal engineer at Red Hat AI. As I already mentioned a bit, we have a lot of things to update. We've had a lot of model releases in the open source AI community, especially DeepSeek v4 finally being released, which I'll cover in some extra detail. We've had a lot of blogs and updates to vLLM in general, like updating the vLLM recipes with a lot more UX improvements, so people can have an easier time understanding how to deploy these state-of-the-art models on release and on their variety of different hardware platforms. And as I mentioned before, vLLM 0.20 was a really big release, lots of changes, important model support. So I'll be going into a deep dive into there on some of the most important features. And lastly, but not least, we'll have an update on tool calling in vLLM and in the latter half. And at the end, we'll have a live Q&A. But please ask questions in the chat all along, and we'll make sure to get to them either at the time or at the end. So to start us off and make sure you know what vLLM is, vLLM is the open source de facto standard for high throughput, memory efficient inference serving of large language models. It's the most popular LLM serving engine used in large scale production. Over 78,000 GitHub stars, 2,000 pull requests we're landing on main every month. It's deployed on millions of GPU hours every day, 24/7, and powers some of the largest deployments of models in the world. We have over 13,000 members on our developer Slack, which you're welcome to join. If you haven't pinged us enough on GitHub, please ping us on the Slack, and we're happy to help you out there. And vLLM's popularity and importance has resulted in dozens of major academic institutions and large companies and enterprises that contribute back into vLLM in upstream open source, with over 2,500 unique contributors adding to the project just within its short, relatively short 3-year lifespan. So the reason why vLLM has become so popular over the years is because of its easy to use interface. It's a Python-based library, just a pip install vLLM away, and then vLLM serve whatever your favorite model is from Hugging Face or from your local disk. And it's able to serve 100 plus, actually now 200 plus different model architectures, and most importantly, running the best state-of-the-art model architectures on launch, like we'll talk about with some of the recent model releases. And of course, it gets great performance for that hardware on NVIDIA GPUs, but also through the software standard that vLLM sets for how to run these models efficiently. There's a dozen plus different hardware backends and plugins that can integrate into vLLM and run these hundreds of different model architectures on Google TPUs, on AMD GPUs, on Apple Silicon Metal, and so on and so forth. So that's obviously a really important part. And maybe most importantly, vLLM is beyond just the inference engine itself. It's a larger project ecosystem where vLLM is a part of the PyTorch Foundation, and we have projects within the vLLM project GitHub organization, expanding into different ways, or ultimately helping the full model deployment pipeline, like compressing your models, quantizing them down, training speculators to serve them faster with speculators, benchmarking your deployment and production with like GuideLLM, building semantic routers on top of vLLM with semantic router, vLLM Omni, expanding vLLM to omni-modality, multimodal inputs and outputs, and so on and so forth. So as you can see, vLLM is a lot of things nowadays. So I'll go ahead and kick off on some of the latest updates over the past 2 weeks since the last office hours. One I really want to highlight, and I invite you to use, but also contribute to if you enjoy it, is vLLM recipes. Now at a new URL of recipes.vlm.ai, has really been rethought and reworked to be much more of a customizable and interactive interface. Most importantly, if you have a model URL on Hugging Face, you can now replace just the huggingface.co with recipes.vlm.ai, and you'll get the exact model card on VLLM recipes for serving that model across a variety of hardware. You can choose different levels of different levels of parallelism, different levels of GPUs like H100s or MI300Xs, and of course TPU support will be added and various other hardware. And if you want to enable tool calling or reasoning parsers or various other features, ultimately it's meant to be a very interactive way, so that you can select and configure the different deployments of your model, and maybe even most importantly, understand what are the verified deployments for a given model that we recommend and the community recommends. So yeah, I invite you to check it out. If you've already seen the old interface, this will be familiar, but hopefully much more fun to use. So thanks a lot. Next, I'm going to cover some blogs that were published either on the vLLM blog or in the larger community. There was this really interesting blog from the AMD embedded LLM folks on their new Mori.io KV connector. This is for transferring the KV cache between disaggregated prefill and decode instances of vLLM, which we have an example of here. But interestingly, they focus on single node prefill decode disaggregation. So people generally think about maybe PD disag is only really useful for cluster scale inference when you're scaling a model across multiple nodes of GPUs. A node only has 8 GPUs, so scaling to a cluster of GPUs. But they find and show and have very strong benchmarks and a write-up detailing how this can be really useful for improving good put or better meeting your latency SLOs while getting better throughput out of your deployment, even on a single node of GPUs. With dense or MOE models that obviously fit well within those GPUs. So I recommend you checking this out. They have this really cool interactive series of diagrams and charts and performance metrics. And overall, it's just a good deep dive into what is good put, what does it mean to hit realistic performance and latency SLOs. This is obviously focused on AMD performance, but you can get some, general knowledge about, realistic LLM serving from this. Next, there's a blog from the NVIDIA developer blog account. NVIDIA has been pushing, a lot of performance improvements in vLLM generally, and here they sort of write through a story of how they optimize the, Minimax M2 series of models on vLLM. Particularly for Blackwell Ultra, so B300s and GB300s. I've been working closely with the team here on landing these changes, and the numbers speak for themselves. Without needing to change anything in the deployment config, just updating the version in vLLM, we're able to see a 2.5x improvement on throughput at a fixed interactivity or latency level across the Pareto frontier on Blackwell Ultra, which is just a great example of how we're trying to improve the default performance of vLLM from release to release to make your hardware purchases more valuable over the previous generations of hardware you're working on, which of course is what we hope software can do all the time, is make your hardware do more for the same amount of money. So yeah, a great example of the performance work needed to utilize the hardware more effectively. Next, actually another blog from NVIDIA folks now at the Jetson AI Lab. So NVIDIA Jetson hardware is generally the series used for embedded or edge deployments on NVIDIA GPUs, or even used in like robotics situations where you want a sort of power restricted GPU box that can be used effectively for edge deployments. And they have a great demonstration of how to use the Gemma 4 models for multimodal inference, reasoning, tool calling, audio processing on the Jetson series of devices, which I think is really cool. And they have some videos as well demoing what you can do with the Gemma 4 model. Yeah, just really appreciate the spelling things out clearly for the application developers who are ultimately trying to build on top of the infrastructure that we built in a project like vLLM. Next, we have a pretty in-depth blog. Obviously, I'm a bit biased. I'm an author on this blog. This was led by Eldar on our team at Red Hat AI, our ML research team, in collaboration with many folks at AWS Research. Yeah, this is a deep dive into the state of FP8 KV cache and attention quantization. Obviously, people are really excited about other types of, or really just KV compression in general, with TurboQuant and other methods that we'll have other blogs and updates on soon. But yeah, there's just a lot of tidbits in here on what you need to do in order to preserve accuracy with this type of compression, what you need to do actually from the kernel level to still get performance out of the hardware while still doing your accumulations in the right order, preserving accuracy, and ultimately getting performance. So I'm really proud of this blog. I think there's a lot of things to go beyond just the standard GSM 8K evals or MMLU evals that people will do. And here, we spent a lot of time obviously covering long context. This like MRCR eval from OpenAI is really useful for this, going beyond just like needle in a haystack for long context, and ultimately trying to rigorously prove that the model across the board, even on deep reasoning and tool calling evals, can be stable as we explore these more aggressive forms of quantization. So look forward to this for going beyond FP8 KV cache and attention. Yeah, please give it a read if you're interested in KV compression. Next, we had a substantial release from speculators, which I mentioned is in the vLLM project, used for training speculative draft models or sort of extensions to your target model on vLLM. This release is really monumental because it formally stabilizes the online training path between speculators and vLLM. So you can have a vLLM server running live and a speculator's trainer hooked up to that vLLM server and getting sending requests in an online way to vLLM and getting the hidden states back out for training in speculators in a live loop, ultimately greatly improving MFU. And speeding up the training rate of these Eagle and now D-Flash speculators. And of course, the other part of this release is adding support for training D-Flash models or D-Flash speculators, which ultimately use block diffusion in order to predict multiple draft tokens in parallel in one forward pass rather than multiple forward passes like needed with Eagle or MTP. Ultimately making the drafting of tokens much faster as we go into drafting, more than just 2 or 3 speculative tokens per request, now 8 or 16 speculative tokens per request, greatly improving, end-to-end latency and driving median ITL down, which, we show in these graphs here of just how much faster the D-Flash speculators can be compared to the Eagle speculators, and then of course no speculative decoding at all. So yeah, please check out the release notes and let us know what you run into training your own models. Yeah, I want to quickly shout out some consequential model releases. We have from Tencent, the High 3 preview model, sort of rework of their foundation model approach. Very impressive in its own right. Followed by Xiaomi Mimo series. There's Mimo V2.5 Pro and Flash. These are very capable agentic models released. And finally, from Inclusion AI, the Ling 2.6 Flash was released, and really all these are rather big models or very smaller performance optimized models, like Ling 2.6 Flash only having 7 billion active parameters, being a pretty aggressive form of MOE sparsity there. So yeah, thanks to their support, and we're really happy to support these models on day zero with vLLM. Now, of course, we have to talk about DeepSeek V4. This was a really consequential release. I think for both the open source AI community, DeepSeek always manages to drive innovation here. And I think especially as someone that's worked in ML systems for a long time, the level of performance and innovation that they drive with the models is really interesting. Here in DeepSeek V4, while it maybe wasn't exactly leading in state-of-the-art open source evals, Kimi K2.6 is still, I think, probably ahead on the eval perspective. DeepSeek V4 does amazing work in terms of compressing the KV cache as aggressively as possible, ultimately making the KV cache almost 9 times smaller than DeepSeek 3.2. Of course, they extended DeepSeek V4 to now have a context length of 1 million tokens. So getting this KV cache to be as small as possible is really critical for efficient management of these long contexts, especially as we have more aggressive prefix caching for these agentic, code agent workflows where they want to, put the whole code base in context or large amounts of the code base in context and do repeated requests at these, using ultimately as much of this context as possible between requests. So supporting this, new type of attention and KV cache compression was a great challenge. And shout out to the DeepSeek team for producing and sharing open source kernels for running these new methods efficiently. The MXFP4, FP8 MOE kernels, the custom attention kernels for these hierarchical forms of KV cache compression. Thanks for all they shared to the open source community. And of course, on our vLLM maintainer perspective, we need to make sure these models are well supported on a variety of hardware. And so I'm really glad that we were able to support, on NVIDIA H200, B200, GB200, even disaggregated serving on GB200 NVL72, as validated on Inference X by semi-analysis on day zero. So thanks to everyone who worked on that. Things don't just stop at day zero. There's a lot of performance work and optimizations and feature expansions to support since then. So, again, shout out to the semi-analysis team for, tracking these improvements over time and, showing us and the community, the difference between the different levels of hardware. For instance, this benchmark on the left showing that B300, this sort of yellowish, brownish line here versus the H200 line here. So being able to get an 8x performance increase, either in latency or throughput, maybe slightly lower for latency. And ultimately, drive performance up across the Pareto frontier as we migrate to the more capable forms of hardware. And on the right, we have an example of running on the exact same hardware. This is a GB200 NVL72 with Dynamo and vLLM. And the only difference is just a few days. You see from April 25th to 29, able to see an up to 60% throughput improvement here at the same interactivity. just through integrating, the mega MOE kernel from DeepSeek, fusing many operations and overlapping compute and communication in the DEP case. There's a lot more to push here on week 2 and week 3. As I mentioned, it's a very complex model architecture to support. I recommend, of course, you check out the vLLM blog that we published for the model. A lot of deep dives into what the model architecture is and what we've done to support it performantly. We also have a tracking issue for the roadmap for optimizing it. I took a lot of time to cover that, so I'm going to try and keep it a bit brief for vLLM 0.20, but this is a huge release, so I want to give it credit where credit's due. It was 752 commits from 320 contributors, 123 of those contributors being brand new to the project. So this is a lot of contribution for a release that's only 2 or 3 weeks from the previous release. Like I said, an insane amount of contribution and collaboration in this project. Of course, we had DeepSeek v4 supported, so you can run it with pip install vLLM. I mentioned the Hive 3 model support as well. We landed initial support in tree for TurboQuant KV cache compression, utilizing the latest configs and optimizations from the community, using ideas from Higgs and other quantization work from even before TurboQuant to make it better than the original paper claimed it would be. And we have a variety of different selections to configure TurboQuant with different amounts of bits allocated to either the key or value cache in vLLM. Of course, we're still expanding support here. Hybrid attention support still is on the way. Its performance is already looking relatively good with Flash Attention supported from Flash Attention 2 all the way up to Flash Attention 4. We've re-enabled FA4 as the default for MLA prefill performance. This is a key note for Blackwell users of DeepSeek models. And we've added MXFP4 weight and activation quantization for the MOE for Blackwell GPUs, rounding out the FP4 support for now for NVFP4 and MXFP4. In terms of breaking changes, we've updated to PyTorch 2.11, which now means CUDA 13.0 is now the default. We worked very closely with the PyTorch team to make sure that this release was planned for that, and so we could make CUDA 13 the default both on PyTorch on the PyPy wheel for PyTorch and the PyPy wheel for vLLM. So now how you install vLLM on say like Grace Blackwell systems or systems that require CUDA 13, it's now just pip install vLLM, and you don't need to worry about setting your Torch backend or getting the right extra wheel index. Greatly simplifying users that have moved on to CUDA 13.0. We still support CUDA 12.9 wheels through wheels.vlm.ai. So don't fret and check out vlm.ai for the setup instructions for that specifically. We've also moved to Transformers v5 as the default release. So a lot more models are supported by default with the VLM wheel and VLM Docker image, which is greatly supported by, greatly appreciated by a lot of users. And we have initial support for Python 3.14, which I hope we can expand and use for less CPU overhead from Python over time. We've also landed the initial online quantization front end. We've had online quantization VLM for a while, but we've wanted to formalize this and start refactoring how this works and ultimately expanding the number of online quantization methods we support. So now we have a bit more verbose methods for quantization. So you can do quantization FP8 per block. Even now, you can do MXFP8 quantization in an online way. And we'll be expanding this to separate weight and activation quantization or mix different schemes of quantization for, say, your linear layers and your MOE layers. We've done a lot of optimizations from actually Roberto, an engineer on our team at Red Hat AI for DeepSeek 3.2 DSA decode, DeepSeek sparse attention decode. This thankfully has been reused for DeepSeek v4 and has greatly improved performance, particularly at very long context lengths, like 128K before, and now obviously 1 million tokens now. We've also been optimizing speculative decoding performance, notably on Model Runner v2. So for Eagle, we have a prefill full CUDA graph, which greatly improves the speculative decoding and verification performance when doing Eagle speculative decoding. Some great performance numbers there within those PRs. A huge variety of other improvements. I have another series here that I want to quickly highlight, the vLLM IR foundation landing. So we've been working on vLLM IR for the proposal and integration migration for a while now. Don't worry, this isn't like a complex compiler IR. It's ultimately just a functional intermediate representation for us to talk about common operations like RMS norms or FP8 quantization, and allowing an out-of-tree, platform agnostic way to talk about these operations that we need in the model graph and allow for multiple different kernel or hardware architecture backends for these various operations. We've had a lot of feature and performance improvements in Model Runner v2, so development there is going along very well. We've also been continuing to refactor MOEs, so more backends use the proper MOE oracle flow, so including the unquantized MOEs and int8 MOEs. Overall, we've also started working on refactoring the MOEs for LoRa inference to improve performance and maintainability in the long term. We've had some improvements on Torch Compile, ultimately enabling more fusions for attention quantization, and also further improving compilation time. We've also been expanding the support for the hybrid memory allocator with KV cache offloading and KV cache transfer. This is very on track with the roadmap laid out there. And we've had a huge amount of hardware support updates, a lot of optimizations on NVIDIA hardware, particularly SM120 and SM110. AMD ROCm adding a lot of support, notably ROCm DFlash support for the state-of-the-art speculative decoding method, and a new Zen Torch CPU backend. Intel XPU is also migrated to Torch 2.11. CPU performance is also going along well across a variety of microarchitectures. We've made as well a lot of progress on large-scale serving, allowing for different EVLB communicator styles, and allowing for heterogeneous TP with MAMA model deployments of PD disaggregation. We've also finally added generative scoring, which is a feature requested by a few different large users of vLLM. So you can now use decoder-only large language models for scoring in a generative capacity. We've been slowly filling out missing features in various APIs that are new in vLLM, like the Anthropic V1 Messages API. So that's all I'm going to cover for now. Thanks for letting me cover all the things that have been going on over the past 2 weeks. And now I'm very happy to hand it over to Rob Greenberg and Benjamin Browning to give us a vLLM tool calling update.
Awesome. Thank you very much, Michael. And thanks everyone for joining office hours today. We're really excited to kind of present out this vLLM tool calling update. So those of you who don't know me, my name is Rob Greenberg. I'm a principal product manager at the Red Hat AI team. And I'll be running through this deck today with Ben Browning, who's a senior principal software engineer at Red Hat. So we'll get right into it then. Okay. So just a quick highlight of the agenda. We'll first start out on a really high level and talk about, what is tool calling? What does this even mean? Why does it matter? Kind of the three-part system that makes up, tool calling in respect to vLLM and what the important pieces are. being the LLM, the chat template, and the tool call parser. We'll talk more about that. How do we actually measure success with tool calling? Where tool calling goes wrong. So we'll look at some common pitfalls. And then we'll kind of dive in on the vLLM tool calling roadmap, focused on this quarter and beyond as well. And then at the end, we'll please save questions for the end. We'll do a Q&A. If you have questions in the chat, feel free to post them. I know Ben will watch it while I'm going, and I'll watch it while he's going. So yeah, let's dive right in. So starting out at a really high level, right? What is tool calling? In the simplest terms, like when a user asks an LLM something that it can't answer from its own, training data alone, such as like, what's the current time in Boston? Or restart this Kubernetes pod. The model needs to go out and call an external function that is basically able to go out there and pull in that kind of structured data that then the LLM gets back and will share with you, the end user, right? So client sends the model a list of available tools as part of the request. The model then decides which tool to call, right? So maybe if you want to know the weather in Boston right now, you would have a get weather tool, right? And this would go out, it would find the weather exactly using, weather.com or something, return that back, and then the LLM would then take that in a structured format and present it back to you, the end user. And basically, this is what tool calling is at a really high level. You can see like a first pass through here, right? We'll go through the user, the LLM, will then identify the tool. It'll then call that tool, get the actual time through an API, give that back. And then that's kind of one loop, right? And as you play with agents and different tools and start using these in practice, you'll see, it's not usually just a single pass through this tool calling loop. The loop actually continues over and over, right? The reason, another really key thing to highlight here and why we're talking about this today with you all is that tool calling happens right here, right? It happens within vLLM. So the responsibility, is on the inference server to actually handle the tool calling, especially when we talk about open weight models, right? And how you can use the latest and greatest coming out of the open source to be able to run effective tool calling and ultimately power your agentic loops, right? So this is kind of how, from what tool calling is all the way to why, vLLM and why we're here today talking about the importance of tool calling. So why it really matters, I'm sure, if we zoom out for a sec, if 2025 was a year of models, 2026 is going to be a year of agents. We've all used Claude Code, I'm sure, either every day or have played with it, or Codex. Understand the power that these agents can bring, not just in software development, but also the world at large. Open weight models, as we've seen over the last 3-4 months of 2026, have made massive leaps in reasoning and capability. And this reasoning specifically is kind of what's powering the next wave of agentic flows and agentic applications. So the model's no longer just answering questions, right? It's planning, it's deciding when to act, reflecting on what came back, and then chaining those steps together. And that's really what the connective tissue is. And tool calling is really the glue that makes that whole process work. So, some of the major forces here, right? MCP, clients and servers are really exploding. So MCP integrations rely on structured tool calling as kind of a key power that they need to have in order to work effectively. Obviously, we talked about agents, whether it's a lane graph or a llama stack or crew AI, the execution loop is driven by tools and reasoning, right? So like the agent is really only as reliable as the tool calling of that model and the server underneath. So this is another really key kind of piece when you peel back the onion of what is an agent. Tool calling is kind of at the core of it. But then obviously, of course, enterprise applications, right? There's a real mandate these days across businesses as well as people building their own startups on how do you actually, garner the power of tool calling and these new models, right? You see a new model comes out, Qwen 3.6 or Gemma 4. How do you actually take that and use that to then build agents in your own applications? And that's been another really big driver of what's kind of drove us to really dig into this tool calling work. So that's kind of a pretty high level view of why this all matters. Getting into some more specifics here. So tool calling is really, you can think about this as like a 3-part system, right? Within vLLM. So you have the large language model, right? This is, a trained model, might be trained for reasoning, trained on really, huge data sets. That's the first piece. Second piece is called the chat template, right? And this is what converts requests into prompts. And then the last piece is the tool call parser, right? And this is, each tool might look a little different. And when you're getting inputs and out, each model actually will have its own tool call parser that will basically help you take that and make it a structured output that then the LLM can process and comprehend that will help drive your agentic application. So the key thing to call out here that's really critical and kind of what drove us to really dive in further here is like, if the chat template and tool call parser are mismatched, the model may generate a valid response, but it might surface as raw text and just raw content instead of a structured tool call output. And what this ultimately does, and no error would be thrown, you would never know, but your agent silently receives and spits out garbage, right? So this is really what, if you've ever tried an open source model, and you go, this sucks, right? This could be the crux of the issue you're facing compared to what you do when you run Opus 4.7 or a leading frontier model versus some of these models, these open weight models. And this is really the bridge that we're trying to gap. So looking at the language model itself, the model isn't just what it answers, it's really how it thinks, right? So modern reasoning models have this thinking block that will call a tool, get the result, and then keep thinking, right? And there's this loop of thinking, calling tools, gathering context. And that second thinking block is where it really gets hard. So the question like every artist needs to think about is like, when the user turn comes in, what do you send back to the model? And each model will handle this slightly differently, right? So a Nemotron versus a Gemma4 versus a Qwen versus a DeepSeek, they all handle this differently, right? So some will just send the recent tool call back, the whole current turn, including thinking, right? All the thinking context in addition to the actual call, every reasoning trace ever, right? Different models have different expectations. And really there's no universal answer. And this is kind of like why we need to move towards more quantitative evaluations, which Ben will definitely talk more about. But ultimately, like there is no unified end-to-end solution, right? And this is really why it's super important to use, what we figured out is using whatever the model vendor recommends is a great starting path. But even beyond there, right, there's more work and more understanding that needs to happen to really use these modern reasoning models effectively. So that's the first piece on the model. The second piece, of course, that I spoke about is the chat template, right? So what the chat template really does is it takes messages and tools from the API request, it renders that as raw text prompt sent to the model, and then basically, it must match exactly how the model was trained to expect it. So like I mentioned on the last slide, each model is a little bit different here. This will ship with the tokenizer usually. So the chat template, if you've ever seen like the tokenizer.json, this is how the model is actually, converting text to tokens and tokens back to text. And this is how it's able to kind of do understanding, right? This is how the model can take what's coming in and out and help render that into what an LLM speaks, into what humans speak. And each model, like you can see here, might have a different Jinja file, which is the template, the chat template that you use for this, that really, is how the model is able to do the tool calling piece and how it's able to understand, right? It's like it's translation harness to whatever tools are out there specific to that model. So even you can see between model families, if you use the wrong chat template, you will get wrong responses, right? And this thing will fail silently and not work the right way. So every model, what we've figured out so far is like there is one kind of right chat template that you can use, and it might not always be the default one that gets recommended. So it is really important that and vLLM recipes upstream does a really good job of publishing for the model providers as well as the model cards on Hugging Face of showing what chat template you need to use that model effectively for tool calling. So chat template is really the second big piece here. Then lastly is the tool call parser, right? And the parser's job is to take the raw token stream coming out of the model and extract it in this structured tool call format, right? So each model, like I mentioned, they also have their own custom tool call parsers. And what this does really is this enables you when you're interacting with these APIs, right? Like a get weather call or a get current time in Boston. When you get that back, the tool call parser is helping you structure that so that the LLM can take it and return it in a way that us as humans and other applications can understand. So this is kind of the last piece that's converting the unstructured text into the actionable formats, right? And then the applications can execute from that. So those are kind of like the three high-level pieces of what tool calling kind of consists of. I'll now pass this off to Ben to kind of talk about how we measure success and the roadmap.
Yeah, all right. Thank you, Rob. So when I jump in, my role in the upstream, my role in my day job is to make these new agentic models work as great as they can with tool calling, right? So how do I know what great is? We have evals, right? So we have a team at Red Hat, but we also have community members that do this, that run different evals, Berkeley function calling, leaderboard, SweBench verified, TauBench. These are all evals that will point at a model running in vLLM to get a sense of its basic capabilities to make sure and fine tune the chat template that Rob mentioned, our tool call and reasoning parsers to make sure we're doing things right. And we're also working with the community. Open Call community has a claw bench coming out, and this is like an agent eval harness. And this will be not just pointing at the inference server in the model, but actually running the full agentic loop through that agent harness against open weight models. And so we're going to start running those as well and making sure we use all these inputs as quantitative ways to refine what we're doing and to clarify our improvements, right? To make sure we're actually making a difference. So that's number one that we do with tool call parsing, right? Now, sometimes things go wrong. Rob touched on a lot of these. There can be some mismatches in configuration, which I'll go over the roadmap, how we're trying to reduce that. There can be some, maybe the user's not educated about what the right things are to use for that model. We've already mentioned recipes.vLLM AI, and we'll talk about we're trying to do things to make it easier for you to find the right configuration, the right tool call parsers, the right templates for your models. And we're working with the model vendors where we can to make sure we get the model cards and Hugging Face themselves, not just the recipe side of data with this. And the biggest thing is, as Rob mentioned, is when you get this wrong, sometimes it blows up, but sometimes you just start getting output, you get tool calls leaked, you're not getting the calls you want. And so just knowing that if you're running an agentic workload or tool calling and tool calls aren't happening, or you're seeing text that looks like a tool call, that's a sign you probably have a misconfiguration. Could also be a sign we have a bug that we need to fix in vLLM. So feel free to reach out in Slack or raise an issue if you're not sure how to track that down. But also make sure you double check the model card and the recipes vLLM website to make sure you're running the right config. Okay. Let's talk about the roadmap. Like where are we going? How are we going to fix some of these issues raised, and how are we going to support the new models? Well, job one for us is always new models, right? There's new models that come out all the time. You saw at the beginning of this presentation, Michael went into all the new models that are out, right? And so every time there's a new model, working with a model vendor to make sure the chat template's set up properly, that we have reasoning parsers and tool call parsers to parse these structured outputs out of the model's generated text so that we can hand them back to the clients over the various APIs we support, as well as running tests, running those BFC evals, running Sweetbench, running vibe checks, right? Like run the model in a Claude code with an open code with insert your favorite deep agent, Claude Agents SDK, OpenAI Agents SDK, whatever you use. Like we do that as well. So I do that regularly when a new model comes out, run a vibe check, see what works, see what doesn't work, test streaming, test non-streaming. That's our everyday work that we do. And that keeps us pretty busy. Here's an example, because we touched on chat templates earlier. I just want you to see an example of when you send a request to vLLM, you're sending a chat completions messages request, or you're sending an Anthropic messages request, or a responses API request. That's not what the model sees. The models have a specific prompt format, a specific sequence of tokens that they're expecting to see. And so our job in vLLM, often directly by applying chat templates, some pre-processing on the vLLM side. Some models, we have special tokenization libraries. Our job is to get the tokens in the exact right order for the model for complex multi-turn workflows. And I've highlighted an example here. This is from a Gemma 4 model of the text representation of the tokens the model sees, right? The model sees tokens as numbers, but these are the text representations. And you can see there's a user turn, and then in the highlighted in yellow is the model's internal thinking. It thinks about what the user asked. It makes a tool call, highlighted in red there. The harness, in this case, I was using BFCL actually to drive this. The harness sends a tool response in highlighted in green. The model reasons about that response. This is what we call interleave thinking. This is the key thing that unlocked agentic, like long horizon agentic planning and task and iteration for us. And you see the pattern of red, green, yellow, like tool call, tool response, reason, tool call, tool response, reason, until the model finds out that line, that last line where it's bolded. The model realizes, I'm done, I finished it, and so it moves on. This is the core thing that we have to get right on the tokenization side. And this actually, subtle changes here have pretty drastic impacts down the line. So we test models regularly. Like I run them with open code and Claude code. I'm going to skip past these slides. If we have time, I'll just show you a live demo at the end. I know we're short on time. I might run over and do a live demo for anyone that wants to see it. The next area we're working on in the roadmap, parsers and test suites. Our reasoning parsers are tool call parsers. They're mostly copy paste from the days of old. We get contributions from model vendors. We don't want to ask them to like refactor and hold up their day zero release. So we'll take it in, we'll take on some tech debt, that's fine. But we have a core team now in vLLM Upstream that's taking on the task of extracting the reusable patterns, adding better test suites, making sure we can do these things, making sure we can maintain these long-term. As well as I touched on our expanded evaluation suites, right? We're regularly running evaluation suites with community partners, with corporate sponsors, corporate partners to make sure we catch the issues. Structured output is the next big thing. You might think of structured output as a user, like, hey, I want JSON. But in our APIs, structured outputs are how we can enforce the model to conform to its special token format, to only generate valid tool names based on the tools you've given it, to only generate parameters and arguments based on the JSON schema you've passed. We don't fully wire in structured outputs today in vLLM in every possible tool calling scenario, especially as you go across our APIs, chat completions, messages, responses. We're going to work on that. That's something that there's multiple RFCs around this in the community. There's various issues and PRs around this. It's something that we need to do to get that next level of tool calling performance. Because no matter how great our models is, when you're 500,000 tokens deep in a context, sometimes, especially depending on how the corrects before that, proceeds downstream to negatively impact your future terms. So we're going to wire this in. It's wired in some cases now, but we're going to expand it as we see success. And lastly, the inference APIs. I mentioned chat completions, responses, messages. These are different APIs clients can use. We want the same model. Choose one model. You should have an equal set of capabilities. Like you should be able to use all the tool calling features of that model across any of these APIs. The APIs are not equal. Some APIs are more advanced than others, but everything should work as well that API can do for that model. Today we have some gaps here and there, so we're going to close those. Make sure that no matter your API, you get the same result. The reason we're doing that is on the right side here, is we want to make sure when you choose a model, it works with any agent purpose, right? We don't want you to run open code and then Claude code and find, oh, it works horrible in Claude code, but great in open code. It should work the same in both. Obviously, there's limitations around like the actual harness and its system prompts and your skills and your prompting. But as far as the inference server support and our ability to support that API that harness uses, we want to make sure that's even across the board, and we're working hard to test and fix any bugs we find there. Feel free to raise those, bring those up. The last thing are the things where it's too easy right now to misconfigure something. We talked about this, like having recipes of vLLM AI to make sure you know where to get your configs from, working with our vendors to make sure all their supported configs are on the model cards and Hugging Face or wherever they host their model. And then we also want to prototype smarter defaults out of the box. Cases where we know as vLLM, like we know the reasoning parser and tool call parser, it's unambiguous. We want to figure out how can we just wire that up out of the box so you don't have to guess and pass the right flags, that we'll just do it for you, right? And that needs a little prototyping to make sure we can do that accurately, but that's totally within scope. And that's something that we're going to try and knock off and see how we can get traction on that. All right, I went quick. We have time for questions. Rob, Michael, you can give me feedback. Do you want to show live demos now with stuff? You want to ask some questions and demo later? How do we think?
We do the demo, and then
go for it.
Yeah, at the end.
All right. Well, here's a little demo. This is Claude Code. I have got a vLLM running. This is with oh wait, I need to share my screen. That would help. I'm gonna take over. Sorry about that. All right.
Please do.
All right. Let's see. You can see my screen now. I'll verbal yes, maybe Michael or Rob.
Yeah.
Yep. All right. So I have Claude Code running on the left. I also have Open Code running. They're both hitting a Gemma 4 that I'm running in vLLM. Let me move this out of the way. I'm running in a vLLM. We can kind of see my vLLM here. Because I'm going to have to type my prompts, I just started out with one prompt that I don't have to type. And I'm just going to let Claude Code go, right? So it's going to do its thing against this self-hosted model. And what I want to show you is tool calling in action. I'm actually going to kick off Open Code 2. We're just going to let them race about it. But these are tool calls. You see here, Python said Claude Code said write main.py. It wrote a file. It called a tool. it thinks it's done. Like, but let's ask it. I don't know if it's done. And so this is what I would call a vibe check, right? It took a good bit of work to get Gemma 4 working well in Claude Code and in open code. All the things we talked about in this, we had to do. But it looks like it started up this little Python process asked it write. It returned hello world, right? Let's see what's open code doing. Open code, yep, it wrote main.py. I'll try and get it to test itself in a minute. Rewrite this example app in Rust, right? These are not hard prompts, but it's showing the ability that it can call tools, it can reason, it can figure it out. I'm running this on a fairly small server at this point. And let's see. Yep, OpenCode thinks it's finished. And let's have it rewrite it in Rust. No, let's have it do in Go, right? And you see OpenCode will show you the raw thinking. This is the model. This is the Gemma 4 model thinking, right? This is not a frontier model. This is running, it's a 31B model. Look, I don't want a plugin, Claude, just do it. So this is not like super exciting because it's working, right? But I would tell you, I don't know if you've ever tried using Gemma 4, Nematron 3, recent Quinn, recent DeepSeek, Kimmy's. There's so many. I don't even want to name them all. I shouldn't have started because I'll forget all the great ones. But there's so many that can just do this now in vLLM, right? They can run tool commands. Yep, hello world, it worked, right? We can edit code. We just spit it out and go run it and see if it works. Again, open code uses chat completions API. You can see down here, maybe you can't see because it's small, but and Claude Code uses the Anthropic Messages API. They're both working. They're both hitting the same vLLM. This is not hard for these models. This is not hard for this vLLM. The server is very underutilized right now. But tell me a story about a dragon and then add that to our code. I don't even know what I mean when I said that. But we'll let Claude we'll let Gemma figure it out, right? So that's it. Everything works, right? Reading files, writing files. I'm letting the context go longer and longer here. You can see we're doing more complex tool calls. It just did an update or an edit. You wouldn't believe the work it required to get those to work properly. This uses streaming support. If we look at my model here, we can see the context we've got available. My Gemma 4 model has 256K context. I've got other videos using a Nematron 3 with 1 million token context. But everything works as you expect, right? I'm gonna stop the demo now. I can show you plenty more later. So no worries there. But I just want to give you a taste. I want you to try it, right? And ask questions and all that. I want to leave time for that.
Yeah, thanks a lot for the very impressive demo. I know myself how hard it is to get these things running and working over the months of it. So definitely very thankful for the work you helped drive in upstream to make these things so much more stable than they were a year ago. Certainly. There's some good questions in the chat. I think maybe we can start with Jay Lee, just like talking about guided decoding as it's kind of parallel but still intersects pretty well. There's several backends as they listed, like outlines, LM format enforcer, or actually maybe guidance is the more modern one there, and XGrammar. How do you implement this? I mean, luckily in vLLM, this is sort of implemented for you. We choose the different backends based on what type of grammar enforcement you need in the structured outputs. So you kind of don't need to worry about what backend is chosen. We end up selecting this for you automatically. One thing that so basically you should just use the feature as you would like in the API through structured outputs or guided decoding in the chat completions API. Sort of more related to tool calling, we have started using structured outputs or rather guided decoding, or specifically the like structural tags specialization of trying to constrain the model's output specifically for tool call output. Or tool call parsing. So the model always produces a tool call for that parses to a valid function. So you're not getting sort of the issue that Ben already talked about of the empty tool response. Maybe it still messes up the tool call itself. It hallucinates a variable or hallucinates a variable value or something, but ultimately it's going to only return valid tool calls to the user. And this is something that ultimately improves accuracy on these tool calling evaluations, improves robustness. So yeah, we definitely want to expand it to more models and deployments. Ben, if you have more you want to add.
Just one thing I'll add is, so we have, for example, Mistral 4 models. We recently merged support for this, that we're on the fly generating the right grammars or structural tags, depending on which backend we're using and which the model vendor prefers, if we're working with a model vendor here, to make sure that the model is always produced following not just your tool call syntax, but its special token syntax. And anywhere else, different models need a different amount of, I would say, guardrails, and guardrails is not the right term, like bumpers, right? Guidance to make sure that they're always, even in deep, long horizon contexts, following their formats. So the biggest thing for tool calling is we're going to start doing this automatically where we can, where we're working with the model vendor to make sure that we're doing it in a way that is never forcing the model to go out of its domain or produce tokens that it would have produced. And so this will be a mostly transparent thing for users. You will just see we'll have stricter compliance with the OpenAI chat completions API and responses APIs about strict function schema adherence and stuff like that. So as we implement it, we'll shout about it and everything, but just as a user, you'll just get better tool calls. That's the main takeaway.
Yeah, thanks. And another quick question, is the model running on local hardware? You want to talk about your setup, Ben?
Yeah, so in that example, I'm on my laptop, so OpenCode and Claude Code are running on my laptop. In this case, I'm SSH port forwarding to a bare metal machine. It's not local, as in it's not in my office right here. It's in a data center. That was an H100 for that model. That was a Gemma 4 31B, so 31 billion parameter model. I happen to have a DGX Spark in my office right next to me. I could have shown it on that. The only reason I didn't is I'm messing with some alternative operating systems on my Spark at the moment, so it's not available to just log into and use. But let's say that you can run Nematron 3, you can run almost any print model with less than 80 gig weights on local hardware, if your definition of local hardware includes things like a DGX Spark.
Yeah, well said. And some of these things even transfer to things like we have a vLLM Metal hardware plugin for Apple Silicon, so you can host models on your MacBook or your Mac Studio if you want, with the same vLLM interface, and use it in a similar way. I think performance is still definitely behind where we're at on NVIDIA hardware, where we spend most of our development, alongside AMD and other more dedicated hardware accelerators or kind of data center ones. But you can definitely run these things on vLLM on your local hardware. Kind of a good question. Do you have to use the vLLM proxy to connect Claude Code to your own endpoint? I think not.
No. It's not going to format well. I would literally paste in the chat the command I used to run my Claude Code. vLLM speaks Anthropic's messages API. That's something we've added, and there were a couple issues that we've worked out as most, to get Gemma 4 around the time we did support for that model. We fixed one final issue that was kind of holding back Claude Code from being great with long horizon tasks. Right now, with the respectable newer open weight models, the command I gave, you can point Claude Code directly at a vLLM. Let's put it that way, right? Now, if you have things between your Claude Code and vLLM, if you're going through light LLM or if you're going through other layers, you have to be careful you're not going through something that is changing or munging with the request or response bodies, because that could impact your Claude Code results. But right now, if you point Claude Code directly at a vLLM, and you have a reasonably recent open weight model, a reasonably recent vLLM, you can expect great results. And if you're not getting that, please open bugs, and we'll go reproduce and fix.
Yeah, well said. As you can tell, Ben and Rob are experts in this stuff, so really appreciate having them around for this. Yeah, any other questions? Feel free to unmute as we're, yeah, want to go through some last ones. Any last questions or general help people are looking for?
Okay. What is open code? Open code is just another open source coding assistant harness, right? I could have shown this with PyCoding agent or Codex COI or Gemini COI or full-side coding. Like, there's a bunch of coding harnesses. Open code is just one that I happen to have, and that I happen to have tested with Gemma for, because I had a specific person that asked me, does it work? And so I already had that running and I knew it worked.
Yeah, there's a lot of harnesses, a lot of models with their particular formats and harnesses they like. So it can get very complex. Yeah, any last questions? If not, we can cut it off there. So thanks everyone for coming to vLLM Office Hours this week. Like I said, thanks to Ben and Rob for covering a great overview into this exciting part of vLLM. Obviously, a lot of new development here, new models that are coming out all the time. Like Ben covered, it's a lot of work to make sure that these models are running as they should, as sort of in sort of a reference way as vLLM is most commonly used for. Huge shout out to Ben and the larger community in vLLM that make sure that these models are running the way they need to run. And yeah, thanks to the model providers or model labs as well for continuing to provide these models and caring about the usage of them. As always, thanks for being a part of the community. We really appreciate any way you can contribute. Coming to this is one way. Opening issues and letting us know issues you're running into with vLLM as you're running it to do your real applications or hobby applications. It helps us know what features people care about the most, what models people care about the most. And of course, if you want to submit PRs and try to fix these things yourselves, we very much appreciate that. Give us any feedback on vLLM Office Hours. If there's other talks you would like to have, special topics like tool calling, or host one yourself, we're happy to take requests or special guests. Just ping me or as we said, comment on this slide. Join us on the developer Slack, and of course, if you're wanting to do open source development as your day job, we're always hiring at Red Hat AI. Our inference engineering team is a great place to work. I've enjoyed it a lot. So join us if you want to work on vLLM. I will leave it at that. Again, thank you very much to our special guests, and thanks to all of you for sticking around for this extra long session. And we'll catch you in 2 weeks at the next office.